6.4 is on dilations. There's going to be easy parts to dilations and there's going to be hard parts to dilations. The first thing that you need to know that are the easy parts. A dilation is either an enlargement or a reduction. You learn this, I can't, probably like 8th grade sometime. I think it's an 8th grade standard where something gets bigger, it enlarges, just like that is an enlargement. That's a reduction. Very simple. You guys understand that. And of course, these things stay similar or are proportional. The hardest part of this worksheet is knowing which one is before and which one is after, which one is the pre-image and which one is the image. So when you get to examples like number 3 came out and I can't see it anymore, so I don't know why. I'll have to figure out what happened there. The solid line is the before, the dashed line is the after. So we'll need to make sure that we know that. Okay? So the thing that I do, that's the easiest part of the whole assignment, enlargement reduction. The hardest part will be the graphing and finding the scale factor. The scale factor, the easiest way I can describe to you how to find the scale factor, it's going to be always be the image divided by the pre-image. Now, if you can figure out image divided by pre-image, it doesn't matter whether you're using the right side and the right side image divided by the pre-image, or the bottom image divided by the pre-image, or the front side divided by the front side, or even the distance between the center and that image divided by from the center to the from the image divided by the pre-image. They all are the same scale factor. You can use any one of the sides or that distance. We'll be using that a lot today. Besides that, the hardest part in my mind is how do we graph. So I'm going to demonstrate what those look like to you so that you don't get stuck as we go through it. Basically, we're going to have to figure out what the distance are horizontally and vertically from that center to each vertex, and then multiply by the scale factor and go that horizontal or vertical distance from those points. I will demonstrate what that means in a second. Let's go to some examples. You guys have number 3 in front of you. If you have your worksheet, go ahead and pull it out. I am going to pull up worksheet 4 real quick. This is what your number 3 looks like, right? You have a 3 and a 6. And there are several directions that are here at the top, and it says the dashed line figure is a dilation image of the solid line figure. The labeled point is the center of dilation. Tell whether the dilation is an enlargement or reduction and find the scale factor of the dilation. So this is the center. The center is in the upper right-hand corner. Let me zoom in on that a little bit. And what we need to do is figure out, is it an enlargement or is it a reduction? And the hardest part, like I said, is which one is the original and which one is the after. If you forget, the dilation image, the dashed line figure is the dilation. Dashed line is the after. The before is the solid. And so if you're looking at this and you're going to use the right-hand side of the image, what is the distance of the right-hand side to this image? How far is the right-hand side? If you know it, say it out loud. I agree. The people who said 9, that is how long it is on the right-hand side. The pre-image, the solid line, the right-hand side is? I agree. It is 3. So let me go back over to this. And we had a little thing like this that somehow got deleted. I don't know where it is, but this is 3. So the image, right-hand side, image, is a distance of 9, and the pre-image distance was 3. This object definitely got bigger. That is called an enlargement. That's the easy question. The harder question, what's the scale factor? It's just image divided by pre-image. 9 divided by 3 in lowest terms. If you say 3, perfect. If you said 3 over 1, okay, you don't have to write over 1. If you write 3 to 1, totally fine. What do I prefer? I prefer 3 because it just means that this is 3 times bigger than the original size. That's all it means. It's the easiest way to write it. So far, so good. Now let's get to the harder questions. Oh, that's what happened to it. This. I see. This should have been here. This should have been there. That's what it was. I had a box covering it. I figured it out after the fact. Okay. So, worksheet 4 is 4 pages long. It has several questions on the same sheet of paper. When you get to either the second page or the third page, what you'll notice is number 6 is in the top left, number 7 is in the top right, and number 8 is in the bottom left corner. When you get there, I'm going to do one example. It doesn't necessarily mean that number 7's question is going to be in the upper right-hand corner. It might be down here. This one might be over there. They do overlap a little bit. Not with each other, they're just in different quadrants. Okay, let's say that. So what I want to do with you is I want to do number 7 together. Number 7 says, dilate this triangle by a factor of 1/2 using J as 10, 4 as the center of dilation, and G, H, and I are listed. So what I think you should do, the very first thing you do, is since you see these points are positive, I would recommend that you label your axes with numbers first. Here's what I would do. I would literally go 1, 2, 3, label your axis. Count them. Don't just guess. Write out what 1 through, and we have to go all the way to number 10. I did a couple extra. And we have to go up to number 14 for our Y, in the Y direction. Once you have your points, once you have your axes labeled, then what I would recommend that you do is that you figure out where your center is. Your center is the letter J. Letter J is at 10, 4. To the right 10, up 4 is right here. Put a dot there, label it. I have to tell you, after looking at second period, they forgot to label their points. Label, what is this? This is J. This is your center. I'm going to switch to a different color. And then I'm going to plot G, H, and I, and I'm going to put those points down and label them. 8, 10. H is 10, 12. I is 8, 14. If you are a particular person, use a ruler. I will use this ruler tool, which, there we go. I love it when it comes out nice and straight. Make another one. That really didn't go where I wanted it to. Maybe I could slide it over. Maybe. What on earth just happened? Technology.
It don't want to work.
Whoa. Don't you love live recordings? Okay, so now I got that back, I think. Well, long story short, let's do that. Let's erase. It won't let me erase. Oh, there we go. I was going to say, what's wrong with this thing? Okay, all right, there we go.
Close enough.
I'm trying to click on this bar, and it's not letting me. And I can't get to the color I want to get to. What is wrong? Yeah, live recordings. Love them, right? Okay.
Looks like you're still building color.
Yeah, I am. We're using blue. Our center is this point right here. The scale factor is a factor of 1/2. We have to go half the size and half the distance. The easiest way for us to do a scale factor of 1/2 will be half the horizontal distance and half of the vertical distance. From where? From the center to each vertex. What does that mean? That means from J to G, or from J to H, from J to I need to figure out what the horizontal distance is and what the vertical distance is. For example, if I go to the left 1, 2, and up 1, 2, 3, 4, 5, 6, 2 and 6. If I went left horizontally 2 and vertically 6, thank you. I'll pass those out later. What would half? That's a scale factor of 1 from here to there. Now I need a scale factor of 1/2. Instead of going to the left 2, how far do I go?
1.
Left 1. Instead of going up 6, I go how far? So left 1, up 3 makes me go 1, up 1, 2, 3. That's a scale factor of 1/2. Instead of me going to G, this is now G prime. We did that to one vertex. We will need to do that for all 3 vertices. What does that mean? From J to H is only vertical. It's vertical 1, 2, 3, 4, 5, 6, 7, 8 units. I need a scale factor of 1/2. That's one scale factor of 1. Half of 8 would be 1, 2, 3, 4. H prime would be here. I'm going to do the same thing to I, except from J, I go to the left 2, up 6, 7, 8, 9, 10. So I'm going to go to the left 1 and up half of 10? 5. 1, 1, 2, 3, 4, 5. I would be right here, I prime. Connect my dots. And what we have is a triangle that is half the size of the original. It's also half the distance between the center and the original shape. If you're wondering, how is this related to what we've been doing? Well, look at the left side. The left side is 4 units. Guess what this side is? This side is 2 units. It's exactly half. If you do the Pythagorean theorem and want to find this distance, it's 2 and to the right 2 down 2, 2 squared and 2 squared. This distance is going to be half the distance, 1 squared and 1 squared. It's going to be half the exact distance there. I want to say this is 2 root 2 and this is 1 root 2. So neat. And it's also half the distance here as it is to there. Really, really neat the way this works. If, let me move this thing right here. If you're doing number 6 and you plot out your points, but now you're doing a scale factor of 4, you might have to go and do, you count left, I want to say it's like right 2, up 3. You might have to do that 4 times. Right 2, up 3, right 2, up 3, right 2, up 3, and so on until you do 4 times as big as what it originally was. I'm hoping that makes sense to you, because that's what 6 is, that's what 7 is, that's what 8 is. And then there's 9 and 10. This is my last example. Shouldn't take us longer than 5 minutes, and then I'm going to give you some time to work on this on your own. So, first thing I do, I have to go negative, positive, negative, positive, negative, positive. I'm going to label my axes, which is, I have to go to negative 13, so I'm going to just label this x-axis, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13. I have to go up to a positive 6. I need to figure out where point P is. Point P is at negative 13.3. I'm going to put a dot there and put the point P. That's your center. I'm going to figure out where A, B, C, and D is. It's going to make a rectangle, it says. A, B, this is your center. I like to think of the center as the projector. This is the thing shining the light that's either going to make something bigger or smaller. It's either your projector or your microscope, depending which way you're going. This one is a scale factor of 3. This is going to create an enlargement. So if I want to know, using a scale factor of 3, where B prime is, the way that I do this, I check horizontally and vertically. Horizontally, I go 1, 2 to the right, up 3. That's a scale factor of 1. If I want a scale factor of 3, I need 2 more of those. Not 3 more, 2 more. This is a scale factor of 1. Going to the right 2, up 3 is a scale factor of 2. Going to the right 2 and up 3 is a scale factor of 3. This point up here is where B prime should be. I'm going to put it in green. Maybe you can see that it's green now. If I'm counting the distance from point P to A and it's 2 units, I need a scale factor of 3. That's a scale factor of 1. I need 3 of those. 1, 2, 1, 2, 1, 2. A prime should be right here. If I want to know where C prime needs to be, I count horizontally. 1, 2, 3, 4, 5, 6, 7 horizontally to the right and 3 up. Well, that's a scale factor of 1. 1, 2, 3, 4, 5, 6, 7, and 3 up. 1, 2, 3, 4, 5, 6, 7, and 3 up. 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. You're just taking the horizontal and vertical distances and you're multiplying them by the scale factor to find out where your new coordinate is. If you know you're going to the right 7, you're going to need to do that 3 times for D. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. D prime. Connect your dots. This green rectangle that I drew is 3 times as big as the blue rectangle that I drew. I could even check the side. This side is 3 units. This side is 9 units. It's 3 times as big. The top of the blue triangle is 5 units. The top of the green triangle is 15 units. Because it's 3 times as big. They all multiply by the same scale factor because we multiplied the horizontal and distances by the same scale factor. Then they're going to ask you some questions. The questions they're going to ask you is, find the perimeter and area of each rectangle from problem number 9. So we're going to use this to answer these questions. I'll do them with you. What's the perimeter of A, B, C, D? Notice there's no, what's the perimeter? Perimeter means add up this distance, 3. I'll put the 3 right there. Add up this distance of 5 with this distance of 3 and this distance of 5. What's the perimeter of A, B, C, D? If you know it, say it out loud. I agree. A stands for the area. Area can be found by adding up all those little squares. But you learned a faster way to do that. Instead of adding up how many squares there are, you learned that you could just multiply the length and the width, or the base and the height, and you can get how many?
15.
Because area represents how many square units there are. Now what about A prime, B prime, C prime, D prime? We have to count up this side, or we know it's 3 times bigger. It's 9 units. 15 units, 9 units, 15 units. What's the perimeter of the green triangle?
48.
I agree. What's the area? You could count up all the squares if you wanted to, but there's a faster way.
135.
Ooh, good job. 135. And then I'm going to answer these questions with you because so many students ask me questions on them. It says, what is the scale factor of this one first and that one second? The original first, that one second. 3 as it compares to the 9 is going to be in this ratio. What is it? It's 1 to 3. Well, why isn't it 3 to 1? Because they told me, write the original first and then the image second. We have to write it in that order. What's the ratio of the perimeters? What is the ratio of this perimeter to that one? What is 16 to 48 reduced to? If you don't know, get a calculator and then do 16 divided by 48. And my calc says 1 to 3. What's the ratio of the areas, though? What is 15 to 135? Let me divide that for you on my calculator. Those aren't the hard questions. The hard questions are when they say, well, what if we replace the 1 to 3 and we replace that 1 with an A and the 3 with the B? The ratio of any length would be... colons. You could use colon too.
Okay.
The ratio of any length. If they replace that with an A and that with a B, notice it will be the exact same as what the ratio of any length would be. A to B. What about the perimeter? How is the perimeter related to the scale factor? It's A to B. It's the same. But the areas doesn't stay in the same ratio. They asked this question. This is something that you were supposed to somehow pick up in 5th grade, 6th grade, but I don't know how many kids actually pick it up. The ratio, how is this related to that in terms of A to B? Well, they're not the same. It's not times 3. It's A squared to B squared. You actually take this one and you can square it, you'll get there. 3 squared, you'll get there every single time. Super hard, super difficult question. That's why I did it for you. I'm going to give you some time.